Hi everyone, my name is Sanya Paglala. I'm the last reporter of the Chapter 8, the Ionic Bonding. So, our last lesson is the formation of ionic compound. So, formation of ionic compound, as mentioned in the previous lesson, metal tend to lose their valence electron, while non-metal gain them. These two individual processes in ion can be considered singly as the exchange of electrons, which actually occurs between metal and non-metal during ionic band formation. When the sodium atom meets a chlorine atom, the sodium atom gives away one electron. This is because sodium has one extra electron in its outer shell and want to get rid of it to become stable. The chlorine atom needs one more electron to fill its outer shell, so it accepts the electron from the sodium. This transfer of the electron creates an oppositely charged ion. Sodium becomes a positive ion and chlorine becomes a negative ion. See the figure of the 8 to 2. The positive and negative charge attract each other, forming an ionic bond which holds the two atoms together. In short, sodium gives an electron to chlorine and they stick together because of their opposite charge. Pauling, PhD, 1901-1994, was an American chemist who since 1990 had studied the structure of molecules and the nature of the chemical bond. He advised on an electronegativity scale for the elements, assigning chlorine as the most electronegative element and fraction of the list of electronegative. Structure. The formation of ionic compound may be represented using Lewis structure. Moreover, the formation of the result of compound between the two elements may be predicted based on the number of atoms or dual atoms. This is a figure of the 8 to 3, one atom each of sodium and chlorine are required to form a sodium chlorine. 8 to 4, one of magnesium atom and 2 chlorine atom are needed to form magnesium chloride. Magnesium want to give away 2 electrons because it has 2 extra electrons that needs to get rid of to become stable. However, 1 chlorine atom can only accept 1 electron. So, to balance things out, 1 magnesium atom give away 2 electrons, 2 chlorine atom each receive 1 electron. Result, 1 magnesium plus 2 chlorine, magnesium chlorine. This means you need 2 chlorine atom to catch that 2 electrons from the 1 magnesium atom. So the figure 8 to 5, 2 atoms of potassium and 1 atom of the sulfur are required to produce potassium sulfur. So this is the figure of another figure of the ionic compound. Potassium atom each give 1 electron. So if you have 2 potassium atom, that 2 electron total, sulfur need 2 electrons to become stable. So 2 potassium atom will give 1 electron, total of 2 electrons. 1 sulfur atom will accept those 2 electrons that form 4 potassium sulfur. So this is the result. So this is the total of the potassium atom with a give electron, total of 2 electrons, and 1 sulfur atom will accept those 2 electrons. The properties of ionic compound. The atom is ionic compound are bound by strong electrical force, ionic bond, which can explain the physical properties of the compound. Ionic compound has high melting point and boiling point. They conduct electricity when an aqueous solution. They also exist as hard but brittle solid at the room of temperature. Ionic compounds are formed when metal transfer electron to non-metal, creating positive and negative ion. These ions are held together by strong ionic bond. Because of this, a strong forces Ionic compounds are very stable. They have high melting and boiling point. At the room temperature, they are hard and brittle solid. When dissolved in water, the ionic separate and move freely. This allow ionic compounds to conduct electricity in aqueous solution. Compound, high melting point and boiling point conduct electricity, solid of room temperature and hard and liquid. The evidence of high melting point and boiling point is this sodium chloride has the melting point of 13 Celsius. The ionic bond that bind the ion are strong such that high energy is required to separate the ion and allow them to move freely and form a liquid or gas. And conduct electricity, the evidence is this. This image. Solid ionic compounds generally do not conduct electricity because their constituent particles are bound by strong ionic bonds in the lattice are dissociated into ion and move more easily. This movement of ion allows the solution of conduct electricity. Some electron compounds can conduct electricity in their solid state and called electrolysis. So the evidence of solid on the room temperature is this image. The chlorine and the sodium. The ionic compound that shown the crystal when the half ion are arranged in alternating sequence that makes the structure stable of crystal lattice is the three-dimensional arrangement atoms in the crystal. And the evidence of the hard and brittle, this image. The ionic compounds are generally hard because of their fixed and stable lattice. This is when lattice are not easily displaced. Most of ionic compounds are also brittle as the external force applied to the crystal. Many distort its lattice and make light change a line shape causing the crystal to break. So this is the last lesson of the chapter 8, the formation of ionic compound. So see you next time. See you next time. Bye. Thank you. Bye.
Chapter 8.
Chapter